the fact that when you put something in a fluid, its apparent weight decreases. And it can let you do really great things, like, for example, you can measure the volume of something or the density of something by weighing it in air and then weighing it when it's totally submerged in water. So Archimedes' principle says that when something is in a fluid, the buoyant force upward, counteracting its downward weight because it's attracted to the earth, depends on the mass of the fluid displaced. So here we have an object, a big chunk of plastic, and we're going to take a look at it, its weight in air, and then we're going to submerge it totally in water, and we're going to do it slowly so that you can see as it goes further and further, as more of the volume is in the water, the apparent weight goes down and down and down until it's fully submerged, and then the apparent weight stays the same. So let's take a look. So our scale says here, the scale is units of newtons. So just this little aluminum cup here weighs about 4 3/4 newtons there. So I'm going to put this mass on here. And if we wanted to know the weight of our cube of plastic there, right now our scale says about 19 newtons. So if we subtracted 4 3/4, that would be the weight of our chunk of plastic. So let's watch. I'm going to raise this container upward of water, and as we raise it upward, there's a little spill valve here. Some of the water will start spilling out into the empty beaker here, and we'll watch what happens to our scale reading as we slowly raise it up, and the plastic gets submerged more and more in the water. All right, so nothing's happening yet because we're not quite there yet. And now we start submerging in the water, and you can see the weight go down and down and down. So when things are in a fluid, the weight will decrease. So now we're going to have to jack this up a little bit to put more of the weight in, and I don't want to go too quick because we will overflow. But now our scale, when fully submerged, now reads about 8 newtons. And so that demonstrates as something gets more and more submerged in a fluid, the buoyant force that the fluid is pushing up with gets more and more. And so the weight will decrease until you're fully submerged and then stay at that value. There's a very practical implication of this if ever you go out fishing, right? Let's say you're deep sea fishing out here off the Pacific coast. You catch a really big fish, you're reeling it in, it feels really heavy. Well, once it gets out of the water, it's going to feel a whole lot more heavier because then you don't have the buoyant force of the water pushing upward against the weight of gravity. So, also works if you're trying to salvage a sunken treasure chest from the bottom of the ocean. As your crane starts reeling it in, you'll feel one value of the weight, but once it starts coming out of the water, that weight will increase and increase and increase. All right, thanks a lot. On to the next video.